Hi guys, this is Divyansh Gupta, CAT 1900 Percentiler from IIMpact.mba. For your benefit, I have launched a free course for the CAT 2025 most probable questions. Check the link in description and enroll now for free. So hi folks, let's start with the discussion of most probable CAT 2025 questions for the generic functions topic. Alright, so question number one. Function is defined for all real values of x and f of x plus y is, let me write it here, f of x plus y is equal to f of x plus f of y divided by 1 minus f of x into f of y. Now they have given me that f of x is never equal to 1 by f of y, which has to be true, otherwise denominator can become 0 there. And they have said all real values of x. Nothing here for us. Now f of n is greater than equal to 0 and f of 2n is equal to 1. What is the value of f of 3n? Now what I have been given is f of 2n and I have to find f of 3n. If I look at this question, they have explicitly mentioned this, that f of n is greater than 0. Now the only reason why they would have to do this is that during the course of solution, I might come across a case where f of n actually can be negative, which I will have to, reject. So, right off the bat, I can feel that some sort of quadratic is going to be, get meet. So, let's start with this. I have f of 2n. I can put x and y as n and n. So, I'll get f of 2n is equal to f of n plus f of n upon 1 minus f of n into f of n. So, this value is given to me as 1. So let me just call f of n as capital Y to, you know, make it more readable. So I'll get 2y is equal to 1 minus y square, or y square plus 2y minus 1 is equal to 0, which will give me y is equal to minus 2 plus minus uh, under root of 2 square 4 plus 4 8 divided by 2, which is going to be, now it is clear, right? Because f of n is greater than 0, I will have to take the positive root. So this will turn out to be root 2 minus 1. So this is my f of n. Now I have to find f of 3n. You can already see they have laid this trap for me. They have put f of n as an option, which, I'm not going to put because I have to solve for this. So this is definitely not the answer. Let's go towards f of 3n. To find that, I'll put x as n and y as 2n. So I'll get f of 3n as f of n, which is root 2 minus 1, plus f of 2n, which is 1, divided by 1 minus f of n, which is root 2 minus 1, into f of 2n, which is 1. So this will become root 2 upon 2 minus root 2. So if I cancel out both the root 2's, I'll get 1 by root 2 minus 1. And if I rationalize this, I'll get root 2 plus 1. This whole product will become 1. So answer will be D. All right, moving on to the next question. For x greater than 1, y greater than 1, this function is defined for me. When x is greater than y, and this is the definition if x is less than equal to y. So let me write this neatly. If x is greater than equal to y, then I'll have to find this expression. However, if x is less than equal to y, then I will have to find this expression. So what they have given me is 6, let's call this as 5, 8. So 6, 5, 8. 6 is less than 8, which means initially I'll have to follow this definition. So 6, 5, 8 is going to be xy, which is 6 into 8, that is 48, 5, x was 6. So I have to now compute this function value. This value is same as this value, and this I can calculate. If you observe in the question, they have given you explicit, value of the function for these cases only. For these cases, for x less than equal to y cases, you have function value in terms of another function value. So I had to make that conversion and I have made that. Now I am in this area where my x is greater than y. 48 is greater than 6, which means 48 5 6 is going to be 2 into 48. I'll just put it here. minus 6 divided by 48 plus 6, which is going to be 96 minus 6, that is 90 divided by 48 plus 6, which is 54. And 18 is a common factor here, so I can cancel that out. So my answer will come out to be 5 by 3, which is D. All right, moving on. So f of n plus 1x is equal to f of nx plus 1 if n is a multiple of 3, and f of n plus 1x is equal to fnx minus 1 otherwise. So let me just jot this result down uh, neatly. Now obviously x is not something which we are playing at. They have given me f1 of 1 equal to 0, and they're asking me for f1 of 50. So I don't really need to write my x here. I'm playing on the nths, the iteration of the function, and not what the actual input is. So I'll write f of n plus 1 is equal to fn plus 1 if n is equal to 3k, and f of n plus 1 is equal to fn minus 1 otherwise. This is what they have given to me. Now f of, or rather let's write it like this, f1 is equal to 0. f2 is going to be, if I put n is equal to 1 here, I will have to follow this definition, right? Because 1 is not a multiple of 3. So f of 2 is going to be f of 1 minus 1, which is 0 minus 1, which is minus 1. F of 3 is going to be again. Now, this is where some confusion can happen. I am finding n plus 1. So 3 is n plus 1, which means n is 2. N is not 3. N plus 1 is 3. So n is 2, which means I will have to again follow this definition. So I'll get f of 3 is equal to f of 2 minus 1, which is minus 1, that is minus 2. Now f of 4 is going to be uh, following the first definition, because n plus 1 is 4, which means n is equal to 3. And 3 is a multiple of 3, obviously. So I will have to follow the first definition now. So f of 4 will become f4, actually, let's call it f4, not f of 4. f4 becomes f3 plus 1. That is minus 2 plus 1, that is minus 1. So you were going minus 1 down, and then you went plus 1 here. Now let's find f5. F5 is going to follow this definition now. Now we can speed up this process because we have realized that the next multiple of 3 will be n is equal to 6, which will give you n plus 1 is equal to 7. So F7 is going to follow the other rule of the addition. Everything else is going to follow the negative rule. So F5 is going to be minus 2, F6 is going to be minus 3, and F7 is going to be minus 2. So now I can form a general result here that f of 3k plus 1 is equal to minus k, because f of 4 is minus 1, f of 7 is minus 2. Similarly, you'll get f of 10 as minus 3, and so on. So this is the observation that I have made. It took some time to get to this result, but you can get to that faster if you don't have to explain, because this observation that the addition step, that this function is going to get used after every third term, right? So f of now, because they're asking me for the value of f of 50, f50, so I will replace k with what? I'll replace k with 16. So f of 16 into 3 plus 1, that is 49, is going to be minus 16. And now I can travel to f of 50 using the second definition. So f of 50 is going to be, f50 is going to be minus 16 minus 1, that is minus 17. So minus of that is going to be minus times minus 17, that is plus 17. So the answer for question number 3 will be plus 17. All right, moving on. Real number x, two definitions of f of x, 1 by 1 plus x if x is greater than equal to 0, and 1 plus x if x is less than 0. Now they have also given me f of nx is equal to f of n minus 1 x. So now they're asking me for f3 So now I can observe that they are asking me for these product of the first five iterations of F3. Now what I can observe is that my input here is 3, which is positive, which means that this definition is not going to be useful for question number 4. So I'm only going to be using this definition because you have x here and x plus 1, 1 by 1 plus x. If x is positive, then this expression is still going to be positive only. So for the next iteration, your input is going to continue to be positive. Right, so I'll find f of 3 as 1 by 1 plus 3, that is 4. Now f of f2 of 3 is going to be 1 by 1 plus 1 by 4, which is going to be uh, 4 by 5. F3 of 3 is going to be 1 by 1 plus 4 by 5, which is going to be 5 by 9. At this point, I can make an observation that for the next iteration, the previous one's denominator becomes the new numerator, and the sum of numerator and denominator of the previous one becomes the new denominator. So this is going to be 14. So you can check this rule. 4 is the denominator here, it becomes the numerator here, and the new denominator is what? 1 plus 4, that is 5. Same thing is happening here also. So I'll get f of 3, fifth iteration, is going to be, this is going to be the new numerator 14, and the new denominator is going to be 14 plus 9, which is 23. So now I have to multiply these numbers. Because the next numerator is the previous denominator, they will all cancel out. So when I multiply, 4 4 cancel out, 5 5 cancels out, 9 9, and 14 14. I am left with 1 by 23. So answer will be option number C. All right, so this is the same question. Let me quickly write the definition again. F of x is equal to 1 by 1 plus x if x is greater than equal to 0, and is equal to 1 plus x if x is less than 0. All right. So for any integer k greater than equal to 2, they are saying we have to find this value. Now, right off the bat, I think the best way to do this is to use the options, or rather put k as something, find that value and pick whatever comes from the option, because they have not given any option in terms of k, which means that whatever value this should give you should be a definite value independent of what you pick as k. So we will pick our k as the most easy to solve for. So let's take k as 2. So they are asking me for f of 1 minus 2 plus f of minus 2 second iteration plus f of 3 of minus 2. So I can quickly run this down. Uh, the input here for the first iteration is negative, right? So this is going to be 1 minus 2, that is minus 1. Now f2 of minus 2 is going to be what? F2 of minus 2 will be f of f1 of minus 2, and f1 of minus 2 was minus 1. So this is f of minus 1. So this will again be what? I'll have to use this definition only, minus 1 plus 1, that is 0. And finally I'll calculate this. So f of minus 2 third iteration is going to be f of second iteration, which we have already calculated as 0. So this is going to be f of 0, and because 0 lies in this definition, I will use this. So this will be 1 by 1 plus 0, that is plus 1. So this cancels out. Your answer will be 0 for this. This is the best approach. You can also go with a standard, take k as something, k as a variable and proceed with it, but in an exam setting this is going to be the fastest method. All right, so for this question we are given f of xy is equal to f of x into f of y, where x is greater than 0, y is greater than 0, and we are given one particular value at 128. I can immediately observe everything is in powers of 2, so that is something I'm going to use at some point. Now this is a function that I can guess, because uh, in the previous questions we had to find the pattern for each and every one of them. We had to find the pattern because the functions were not easily guess, something that we could easily guess. This one we can, this we have seen in the class also, in a revision lecture. You can refer to that as well. So I will say that f of x is actually x to the power a. This is an exponential, right? Because that will make f of xy as x to the power a, y to the power a, which is what they want from me. Which means that if I follow this definition, then 128 to the power a is equal to 8. This is 2 to the power 7a is equal to 2 to the power 3, or a is equal to 3 by 7. So I know that my function f of x is actually uh, x to the power 3 by 7. Now I can go ahead and put this in all of this. So I'll get 1 to the power 3 by 7 into 2 to the power 3 by 7 into 4 is what? 2 square. So 2 into 3 by 7 into 2 cube, that is 8, 3 into 3 by 7 till f64, which is 2 into sixth power, 2 to the power 6 into 3 by 7. So when I multiply this, I will write the base here and I will have to add the powers. If I take 3 by 7 common there, I'll get 1 plus 2 plus 3 till 6. This is sum of first n natural numbers, which is going to be n plus 1 into n divided by 2. I have this 3 by 7 sitting outside. This whole thing to the power 2 is going to, 2 to the power, this whole thing is going to be my answer. So 7, 7 cancels, this cancels. 2 to the power 9, which is 512, is going to be the answer for this question. All right, let's proceed. Question number 7, f of x is equal to 25x. So let's write this expression. 25x upon 25x plus 5. They are asking me for some of these 98 terms. So right off the bat, I cannot add, or rather I cannot find each of these individually and then add them. That is not possible for me, which means that I will have to find some way to reduce my effort, find some sort of pattern. Second thing that I notice is that alternate terms add up to 1. So maybe the inputs that add up to 1 are going to give me a fixed output, which is something I can use. So let's use this. Let us find f of 1 minus x. F of 1 minus x is going to be 25 to the power 1 minus x divided by 25 to the power 1 minus x plus 5, which is going to be 25 divided by 25 to the power x into 25 upon 25 to the power x plus 5. Right, so if I multiply, if in the denominator, this will cancel out and this will become 25 to the power x. Now if I cancel out the 5s, I will get this as 5 by 5 plus 25 to the power x. This is f of 1 minus x, this is f of x. If I add these two, what will I get? The denominator is same for both, which means 25x plus 5. I'll take it common. 25x plus 5. That is 1. So the sum of the terms equidistant from the either end is a constant number 1. So how many terms are total present? 98, which means I have 49 such pairs and sum of each pair is equal to 1. So my answer is going to be 49 into 1, that is 49. So answer for question number 7 is 49. This is a very standard question, something like this. I mean, this format where, they ask you for somewhere the sum of inputs from either ends is a constant number. So we should try for that. How I decided on this one? Because 1 by 99 plus 98 by 99 is 1. So putting x is equal to 1 by 99 here will give me this plus this in this expression. All right, moving on. F of x is f of x minus 1 minus f of x plus 1. They have given me two f values. I have to find f of 7. Now, this is a clear case of, some sort of Fibonacci thing happening. That is not entirely relevant to the syllabus. What it means for us is that sum at f of x plus f of x plus 1 is actually equal to f of x minus 1. So the previous term is the sum of the current term plus the next term. So I'm been given f of 1, I'm been given f of 4. So I'll have to use this to find, you know, f of 7. So some intermediate variable is going to get involved. So let's start. F of 4 is going to be f of 3 minus f of 5. All right. F of 3 is going to be f of 2 minus f of 4. All right, and I know f of 4, so this is going to be f of 2 minus 1. f of 2 is going to be f of 1 minus f of 3. Yes. And f of 3 I know in terms of f of 2. So I can substitute that. I can substitute the value of f of 1. So I'll say f of 2 is equal to 3 minus f of 2 plus 1. Basically, I substituted f of 3 value here, which will give me f of 2 as 4 by 2, that is 2. So now I have f of 1 as 3. I have f of 2 as 2. I can find f of 3 now. I know f of 3 is f of 2 minus 1. So that is 2 minus 1, that is 1. And f of 4 is equal to 1. Now I can proceed upwards. I have found every term that I needed to. F of 5 is going to be f of 3 minus, sorry, yeah, I will now use this to find f of 5 first. F of 4 is 1, f of 3 is 1, which means f of 5 is equal to 0. So now f of 5, which is equal to 0, is going to be equal to f of 4 minus f of 6, which means f of 4 is equal to f of 6, and f of 4 I have gotten as 1. It is given to me as 1. So f of 6 is equal to 1. Now I'll proceed to f of 6 is equal to 1 is equal to f of 5 minus f of 7. F of 5 is derived as 0. So 1 is equal to minus f of 7, or f of 7 is equal to minus 1. So in these sort of questions, this is the pattern you will have to follow. Whichever terms they give us, we'll try to connect those, finding the intermediate term and then traveling towards whichever direction they want us to go to. All right. So moving on, the next question is f of x is equal to x cube minus x square minus f of x minus 1. F of 1 is given to me as being equal to 1, and I have to find the value of f of 25. Now, right off the bat, this is a bad question to take up in the exam. This is a trap. The reason being that while we can see that f of x plus f of x minus 1 is equal to a polynomial, we would not be able to guess what that polynomial has to be, because it will be at least a biquadratic, a fourth power polynomial. So it is not possible for us to guess that. It will become very ugly. So I will have to find these expressions and add them and get to my answer. So let us proceed. F of 25 is going to be 25 cube minus 25 square minus f of 24. Now f of 24 also I can replace by using this again. I'll get f of 25 is equal to 25 cube minus 25 square minus 24 cube plus 24 square uh, plus, or rather, plus f of 23. Now again I can replace this with f of 23 using this iteration, and I will eventually land at f of 25 is equal to 25 cube minus 24 cube plus 23 cube minus 22 cube and so on till 2 cube uh, minus, now you have 25 squares starting with minus 25 squares, so 25 square squares, then you will have minus you know uh 24 square and so on till 2 square, and you will be left with f of 1 at the end. uh a tricky expression, so to say. The only saving grace here is that the negative signs are bundled together with the eventh term. So I can write this as 1 cube plus 2 cube till 25 cube minus 2 times uh, 2 cube plus 4 cube plus all the even cubes till 24 cube, and then I can take 2 cube common, so this will become 16 into 1 plus 2 cube plus 3 cube till 12 cube. So this is sum of first 25 cubes minus 16 times sum of first 12 cubes. So and I will need one cube here, so I'll do one minus cube here. So I will find this entire value uh using the formulas, and you will get this as 8 to 8. 0. Similar reasoning you can apply here, and you can solve that, and you will get this expression as 324. So your final answer will turn out to be 820 minus 324 plus 1. That is going to be equal to uh, 7957. So this it is a bad question in that sense. Bad again, it's not a bad question. It's just that it is something which is uh, going to take up a lot of time. I have skipped the calculations over once I got to you know the expression for which I know the sum formula. But even then, after that, the part I've skipped over, the calculation part, that is going to be tricky. All right, moving on. So we are given x plus 1 by x is equal to 1, and we have to find the value of this question. Now, in this particular question, it is very easy to jump the gun, because this is an expression I hope most of you are familiar with right now. You see this in AMGM, you see this in a lot of places. When you are asked x cube plus 1 by x cube, those sort of things. So you might feel tempted to divide this entire thing by x to the power 12, which is the highest power, which will give you, or rather by x to the power 6, which is the middle term, and you will get x to the power 6 plus x cube plus 1 plus 1 by x cube plus 1 by x to the power 6. Now this plus this and this plus this, you can find using x plus 1 by x is equal to 1, which is something cat has asked multiple times by now. But for this particular question, there is something else that we could have noticed, which is that the powers of multiples of 3, they are working in cubes. So let me just for a second you know uh, revise this equation in a format where I can get the value of x cube. See, we know that the value of x is going to be ugly. It might not even be real. But what about the value of x cube? So let's just try that. We'll get x square plus 1 is equal to x. So this will give me x square minus x plus 1 is equal to 0. Now, if I multiply both sides with x, I will get x cube minus x square plus x is equal to 0. Now, x cube turns out to be x times x minus 1. If I manipulate this expression again, right? If I write this as 1 by x is equal to 1 minus x, and I cross multiply, I'll get 1 is equal to 1 minus x into x, or minus 1 is equal to x minus 1 into x, which is what I'm getting the value of x cube as, which means x cube is equal to minus 1. And that makes this question so much more easy to solve, because I'll just put this here. This is minus 1 to an even power, so plus 1, minus 1 to an odd power, so minus 1, minus 1 to an even power, so plus 1, minus 1 to an odd power, minus 1 plus 1. So this is going to be plus 3 minus 2, that is plus 1. So again, a much better way exists to solve this particular problem. All right, moving on. A function n is defined, f of n, that f of n minus 1 into 2 minus f of n is equal to 1 for all natural numbers n. This is a point function. You can refer to the lecture recording for this to understand what that means. This is a point domain function, which means, any guessing for the function itself is not going to be very, conducive to our effort, which means we must rely on finding some pattern, because f of 1 is given and I have to find f of 21. All right, so let us proceed. If I rearrange this, I'll get f of n is equal to 2 minus 1 by f of n minus 1. Now I am being given f of 1, so I'll get f of 2 is equal to 2 minus 1 by 3, which is uh, 5 by 3. Now f of 3 is going to be 2 minus 1 by f of 2, which is 2 minus 3 by 5, which is going to be 7 by 5. F of 4 is going to be 2 minus 1 by f of 3, which is 7 by 5. So 2 minus 5 by 7, that is 14 minus 5, that is 9 by 7. At this point, the pattern becomes clear. These are consecutive odd numbers, and so are these, and they are just the difference between denominator and numerator is 2. So I can write this using this expression. I can write f of 4 is actually 2k plus 1, or rather f of n is equal to 2n plus 1 upon 2n minus 1. So if n is 4, f of 4 is 2 into 4 plus 1, that is 9, divided by 2 into 4 minus 1, that is 7. So this guessing works for me. They are asking me for f of 21. So f of 21 is going to be 2 into 21 plus 1 divided by 2 into 21 minus 1. So that is 43 by 41. Option number C. All right, let's proceed. Okay, so we are given f of x and g of x, and we have to find f of g of f divided by g of f of g at x is equal to 2. So in questions like this, where we have to calculate the composite function, first write the clear definition so that you don't get confused which is what. Secondly, start from the inside. So let me first calculate what g of fx is. So g of x is 3 to the power x. If I replace x with f of x, I will get g of f of x is equal to 3 to the power, replace x with f of x, that is x cube. Alright. Now I am going to put this as an input in the f of function to find this overall, my numerator. So I will replace x with this function, which is this. So f of g of f of x is equal to 3 to the power x cube whole being raised to the power 3, which I can simply write as 3 to the power 3x cube. This is f of g of x. Similarly, I can find g of f of x. So I'll get, first I'll have to find f of gx. So f of gx, this is going to be, I'll replace x here in my f of x definition with gx. So this is going to be 3 to the power 3x. Now this gets put back into g of x as an input. So g of f of g of x is going to be 3 to the power 3 to the power 3x. Now this thing is getting divided by this. So this is going to be 3 to the power 3x cube minus 3 to the power 3x. Now we can put x is equal to 2. So I'll get 3 into 3 raised to the power 2 cube, that is 8, minus 3 to the power 3 into 2, that is 3 to the power 6, which is 3 to the power 24 minus 729, which is 3 to the power minus 705. So my answer will be option number D. All right, let's proceed. F of x plus y is given to me as f of x into f of y for all xy, and f of 6 is given to me as 10. Now, for the guessable part of the function, we can actually make a guess here. This is going to be what? This is going to be, you are given f of x plus y is equal to f of x into f of y. So we can replace f of x with a to the power x. So this will become a to the power x plus y is equal to a to the power x into a to the power y, which is a to the power x plus y. So this is correct. So this definition f of x is equal to a to the power x is correct. So we are being given f of 6 is equal to 10, which means a to the power 6 is equal to 10, or a is equal to 10 to the power 1 by 6. Now I will put minus 24 here. I need to calculate a to the power minus 24. So I'll substitute the value of a. 10 to the power 1 by 6 into minus 24, which is 10 to the power minus 4. So answer will be option number A. All right, moving on to the next question. Now f of x is given to me as f of x minus 2 plus x into x minus 2. I am given f of 1 plus f of 6 as 0, and I have to find these 6 sums. Now, this is a good question because it sort of confuses me as to what should I do. What are the alternatives? Can I guess the function? this difference of the functions is coming out to be quadratic, which means that the functions are most probably cubic. I can feel like that I can guess that, but that will involve three separate equations that I have to solve to find a, b, c for the ax cube plus bx square plus cx. Not worth it. Secondly, this is defined for point domain, right, for all integer values, which means that maybe the cubic definition, even when I get abcs, does not work. So that would have been a bad approach to guess what the function is. So which means I will have to go and look for some patterns. Now one may ask, I only have to find sum of six terms, so might as well just calculate each individual term. Why, go to the hustle of finding some pattern? And I would be inclined to agree, but the pattern actually lies in finding this sum. So let's proceed. You will have f of let's start with f of 2. F of 2 is going to be or rather let's first start with f of 6. F of 6 is equal to f of 4 plus 6 into 4, which means f of 4 is equal to f of 2 plus 2 into 4. Now I can express f of 4 in terms of f of 6. And because I can express f of 2 in terms of f of 4, which means that I can express f of 2 in terms of f of 6. So I am getting f of 4 is equal to f of 6 minus 24. And f of 2 is f of 4 minus 8, which means f of 6 minus 32. These two I have converted to f of 6, and f of 6 is equal to f of 6. Why am I working it like this? Because the differences are 2. So if I take x as even, I'll be dealing with evens. This is even, this is even. So I'll make a series for the even ones and I'll make a series for the odd ones. So what will be the series for the odd ones? I'll have f of 5 is equal to f of 3 plus 5 into 3. And I'll have f of 3 is equal to f of 1 plus 3 into 1. So from here, I can get, I have f of 3 as 3 plus f of 1, and I have f of 5 as 15 plus f of 3, which will mean 15 plus f of 3. So 15 plus 3 plus f of 1, which means 18 plus f of 1, and f of 1 is equal to f of 1. Now if I add all of these, I will get this plus this plus this plus this plus 3 times f of 6 plus 3 times f of 1, and f of 1 plus f of 6 is given to me as 0. So my answer will be 3 into 0 plus this 18 plus 3, that is 21, minus 24 plus 32, which is 56, and whole mod of this. So this will be 35. Otherwise, this question can take up a lot of time if you go for something else. So you converted what was being asked into the one thing that I know about. All right, moving on. F of x plus 2 is equal to f of x plus 1 plus f of x. F of 23 and 28 is given, and f of 21 is being asked of me. So this is again a similar Fibonacci type thing that we previously discussed, right? You have to start writing. So let's do that. F of 25 is going to be f of 24 plus f of 23, which is 71. Let's call f of 24 as b. So this is b plus 71. F of 26 is going to be f of 25, which is b plus 71, plus f of 24, which is b. So this will be 2b plus 71. F of 27 is going to be this plus this, that is 3b plus 71 into 2, that is 142. And f of 28 is going to be this plus this, sum of the last two terms. So that is 5b plus 71 into 3. It's been taken three times. So 213. And this value is given to me as 528, which means b turns out to be 528 minus 213, that is 315 divided by 5, or 63. So f of 24 I have gotten as 63. So I now have two consecutive terms. So I can make my way back. F of 24 is going to be f of 23 plus f of 22. So this is 63 is equal to 71 plus f of 22, which means f of 22 is minus 8. Now I'll write f of 23 is equal to f of 22 plus f of 21. F of 23 I have a 71 is equal to minus 8 plus my answer. So my answer turns out to be 71 plus 8, which is 79. So, set approach for this Fibonacci types question, where sum of consecutive or the difference of consecutive terms is equal to the next or previous term. It is a set approach. It's just that uh, it takes up a lot of space and a lot of time. So maybe you should attempt this when you have that sort of time available to you. All right, moving on to the next question. Now f of xy is equal to f of x into f of y. Now this is a good example of why guessing might not work. Why guessing the function might not work. So this is given to me. So I can hypothetically say that this is actually f of x is actually a, or rather uh, x to the power a. This definition would fit here. You will have x to the power a into y to the power a, which is xy to the power a, which is what this side input would have been. So that way this function, this definition works. We can quickly check also. Xy to the power a is equal to x to the power a into y to the power a. That is correct, right? But f of 1, 2, and 3 are positive integers. This is an additional constraint that has been introduced. I am given f of 45 is equal to 175. So 45 to the power a is equal to 175, or a is equal to log 175 base 45. Now would 2 to the power log 175 base 45 be an integer? We know it is not going to be an integer, right? Because this itself is not an integer. Right, and if you can take the 2 upwards, you can also write 3 to the power log 175 base 45. Do we know that this will be an integer or not? We don't really know if this will be an integer or not. So that way, because this is defined for a point domain, point value domain, even though our guess is correct, this would have fit, right? But it sort of is risky here, because then what your answer would be that I'll say f of 15 is equal to 15 to the power log 175 base 45. Now there's no way for you to calculate what this value is, and you don't even really know if this will turn out to be a integer, which is something it should, because it's a theta question. So we will go with some different approach. The thing which was causing us an issue, we will use that. The thing that was causing us an issue is that these are integers. So let us leverage that. F of 45 is going to be f of 9 into f of 5, and f of 9 is going to be f of 3 into 3. So this is f of 3 square into f of 5 is equal to 175. Now if f of 3 is an integer, what possible value can f of 3 take? Wouldn't 175, we'll factorize f 175 and we will get 175 is equal to 25 into 7, which means f of 3 is 5 square and f of 5 is 7. So f of 3 is equal to 5 and f of 5 is equal to 7. And now we can use this. We need to find f of 15, right? So f of 15 will be f of 3 into f of 5, that is 5 into 7, that is 35. So answer for question number 16 will be 35. All right, folks. So let's start with question number 17. We are given f of xy is equal to f of x into f of y plus f of x plus f of y. And f of p is given to me as 1 for every prime number p. I need to find f of this very large number 2278125, which I obviously cannot do manually, which means I have to develop some sort of pattern or some observation has to be done. The observation is clear. All these options are 2 to the power something minus 1. So I will now try to think in that direction. One good approach in these sort of questions is adding plus 1 on both sides, which will make this 1 plus f of xy is equal to 1 plus f of x into 1 plus f of y. Now I can define g of x as 1 plus f of x, which will make this entire thing as g of xy is equal to g of x into g of y. Now this helps me a lot. Why? Because my initial definition, the f definition, had product plus sum. I'm now able to convert it into something where g of xy, product of inputs, is product of individual outputs. This is much more easy to manipulate. The rule obviously will change here because g of x is equal to 1 plus f of x. If I put x as p, I will get g of p, a prime number, is equal to 1 plus f of p. And f of p is given to me as 1. So g of p is equal to 2. So I will use this rule now. So basically, if xy is something that I'm giving as an input, and if I can keep on factorizing it, I will essentially get to a position where I can write this as g of p into g of p into g of p. How many times? The number of, primes it take to make my xy. So that is what this question reduces to. I need to convert this into its prime factors. So I will quickly do that. One easy trick for this: 125 divides 1000, which means that uh, these three digits, 125 is divisible by 125, and 2278000 will also be divisible by 125. So this entire expression is divisible by 125. So this becomes 125 into 18225. Now, same logic, 25 divides 100, and the last two digits are 25, which means this entire thing will be divisible by 25, and you can factorize this as uh, 25 into 729. So your factorization turns out to be this entire thing is 5 to the power 5 and 3 to the power 6. So it takes 11 prime factors to make this number. So my g of this thing is actually 2 to the power 11, which is 1 plus f of x. So f of x turns out to be 2 to the power 11 minus 1, which is 2047. So this is a good approach to do these sort of questions. You could have started with the prime number itself and developed it upwards, but that would have been probably a bit more lengthy. All right, moving on. So xyz's are real number and xyz product is equal to 1. So I'm given 1 by 1 plus x plus 1 by y plus 1 by 1 plus y plus 1 by z plus 1 by 1 plus z plus 1 by x. So I'm clear right now. Taking values of x, y, z is not going to help because these two options would give me the same answer and these two options would give me the same answer. So I still have to probably calculate this. So I will probably go with eliminating z. So I'll replace z with 1 by xy everywhere. So this will become y by uh, y plus xy plus 1 plus 1 by 1 plus y plus xy. Z is 1 by xy, so 1 by z is xy plus 1 by 1 plus 1 by xy plus 1 by x, which will become xy. This thing will become xy plus 1 plus y, and xy will go on the top. So now, if I let's just remove this, you will get that the denominators are same for each. That is 1 plus y plus xy. The numerators are y plus 1 plus xy. So the numerator and denominator are same. So this value will turn out to be a constant number 1. Putting values could have gotten you here. Maybe you could have tried a different combination, but because it's a mix of constant and expressions, you always run the chance that you unluckily pick the values which give the wrong answers. All right, moving ahead. This function is defined a star b is equal to 2 minus ab. Then how many of the following statements are true? Now, right off the bat, the order of A and B does not seem important. What is important is what the product AB is. So let's start with this. 3 star 2 is going to be 2 minus 6, which is uh, minus 4. and 2 star 3 is going to be 2 minus 6, which is minus 4. And now I have minus 4 star minus 4, which will be 2 minus minus 4 square, that is 2 minus 16, that is minus 14. So this one is correct. Second one is 4 star 2 into 2 star 3 is equal to 1 star 6 into star 8 star 1. Now 4 stars 2, or let me just write this here. 4 star 2 will depend on the product of 4 into 2. That would have been 8, which is same as product of 1 and 8. So these two terms will give the same value, and these two terms will give the same value, and their individual stars, because the order of star does not matter, will give the same value. So this is correct. I don't really need to check this one. The next one will be third option. Minus 1 star 2 is going to be 2 minus minus 1 into 2, which is minus 2, that is 4. This will give the same, that is 4. So I have 4 star 4 as equal to 2 star 8. Same thing, 4 into 4 is 16, 2 into 8 is 16. So this will also be correct. So this is the last one that I need to check. I have 6 star 1 into 3 star 2. So this will be 2 minus 6, that is minus 4. And 3 star 2, 6. 2 minus 3 into 2, that is 6. So this would be giving the same value. So minus 4 star minus 4. This is 1 into 2. So 2 minus 2, that is 0. And that is 7 into 3, 21. So minus 19 star 0. Is this equal to minus 4 star minus 4? So you can quickly check. This will be equal to what? This will be equal to 2, because there is a 0 sitting here, and this is not going to be equal to 2. This will be 2 minus this, we have already calculated, actually is minus 14. It's not equal to 2. So this is incorrect. So there are 3 correct statements here. All right, moving on to the last question. If x is a real number such that g of x is minimum of a linear and a linear, then the maximum possible value of g of x is. So for these sort of questions, the best way is probably to just make the graph for yourself. Let me first draw 7 minus 3x is going to be something like this. It's going to be something like this. Uh, positive intercept of 7 and negative slope of minus 3. The second one will pass through point y is equal to 3 with a slope of 5. So it will go like something like this. Now this function is taking the minimum out of this, which means it will take this value because it's below the other graph, and then it will switch to this graph, because then this one will shift. So this is going to be the graph of this function. The maximum possible value is actually at the intersection point of this. So 7 minus 3x is equal to 3 plus 5x. If I intersect this, I'll get 4 is equal to 8x, or x is equal to 1 by 2. If I put this back on any of this, I'll get 3 plus 5 by 2, which is 11 by 2 as my answer. So option number C.